Hello and welcome back to Universe Sandbox 2. So today we are going to be, doing stuff in the universe. So we basically have DX Story back working again, which is exciting, a new version of it. It works on this version of Windows or whatever broke it before, and apparently it's faster, so we will see how that goes. So the first thing we're going to do in this video is we're going to correct my mistake in the last video. If we go to the RIPPER, I did actually make a serious mistake here because I was looking at the simulation. Now, how do I change the background? People keep saying, Spike, you can change the background. But I don't actually 100% know how to do that. I'm assuming it's somewhere in here. Somewhere, possibly. Background, come on. Well, maybe I'm just really bad at my job. Or maybe it's some weird thing somewhere else. But I don't know. I apologize. Although, there are some settings in here I just have never messed with before. The Debug Tools, those may be cool to look through at some point. But it's fine. For the most part, we can see the black holes. And if we look at them, we can see that these, actually, if I do this, they will be visible. Okay, so you can see all of them here, and then the center is here. Now the problem is I was looking at it as if these were to the side of the center when really they're diagonally to the center, but this is an easy fix. All we have to do is move them. Well, that's easier said than done. So, if we can find the one that's in 0, 0, 0 position. Oh, that was easy. Then this one should be 1, 0, 0. Okay, so it's like this. And what we have to do... Okay, this is slightly more complicated. No, it isn't. No, it isn't. Because I can do that, which brings that to an equal distance there. Then I can move this one into its position. Okay, so if I do 1, and then I do... So if I switch that to 0.5, that'll move there. And if I move this... Oh shoot, no, I messed that up. Can I undo? Yes, I actually can. Okay, so let's look at where I messed up there. So one of these needs to be changed and the other one does not. So maybe it's this one. Yep, that looks... Shoot. This is so complicated. And now this one we're going to have to move to 0.5, 0.5 I think. Or 0.5 AU 1 AU. And that is the corrected version of the RIPPER. So, there we go. And you may be asking, so what does this do? Well, if you haven't seen the previous video, it rips planets apart equally on each side. Or at least it was supposed to. And we will show this using Earth. And let's just grab Earth, place Earth kind of in the middle, get Earth, put it in the exact middle, which is half an AU in each direction. So let's just use 0.5 AU. We can actually copy that, paste it, shoot. And yes, it has to be perfect or else this will not work correctly. And we accidentally did it in orbit mode, but that's fine. We can go 0 velocity, and now it's in the exact center. So this is where it gets exciting. We're gonna turn down time a little bit, and now we're going to watch the effect. So if I speed up time a little bit, just enough that we can see the effects, we should any second now see matter ripped out of Earth in every direction. It will be pretty intense. Come on. Come on. Show us. Show us the greatness. Oh! That was weird. It instantly ripped itself apart. We weren't even going that fast. We're going to have to redo that. Okay, so first let's save this as the Ripper because it's the better one. And I'm being slightly spammed here, but let's just ignore that. So if we put another Earth in that spot, turn down the time a little bit, we did get a huge response there, but it was so quick that we didn't even see what happened. But it is certainly fine. We just have to go in and go slow. We'll go out. This speed should be safe. So how long is it going to take for that effect to happen here? Now, I do apologize for doing 2 videos on the same thing in a row. It's just, I think this is once this is working, this is going to be an awesome thing to experiment with in the future. We just have to get it working properly, and last time I did mess up, I'll admit 100%. I was not thinking clearly when I set it all up. But now, any second now, we're going to see the explosion that we saw before, or Earth just being ripped apart. We're going about 1/40th of the speed of before, so it may take a little bit for the reaction to start, but we are going to see it. So we see a velocity, and we don't want that. It's actually gaining quite a bit. What we should probably do, what's probably going to happen is it's going to move more towards 1, and then it's only going to be ripped apart by that one. So when we had 4 black holes, this was pretty simple, and it worked pretty well. It seems that adding the 2 more on the top and bottom have seriously complicated this, because they're all pulling equally in opposite directions, which means that technically it's kind of like air pressure. You don't notice it because you're being pulled in every direction the same amount. So it actually equals 0. Now, here's where that's not right. If you think about the Earth like this, the Earth is not one point in space. Each point on the Earth is another point in space. So if we take, say, America right now, America is closest to this black hole over here, where China would be closest to this black hole over here, meaning that America would be being ripped towards this black hole faster in this direction than China would, because China would have more attraction to this side. It would be a minuscule change, but with black holes that large, it would actually make a difference. I'm not going to do the math because I feel like that's going to be extremely complicated. Actually, maybe I will do the math at some point. We'll see. But the problem is, in a computer simulation like Universe Sandbox 2, I'm pretty sure they just currently do 1 point for all the calculations, and that's usually all you need. But in our case, that may not be enough to get an accurate simulation. I'm hoping in the future they use some sort of voxel system where planets are actually made out of tangible stuff you can dig and rip, but that's a lot of work, and I'm not sure if that's ever going to happen. So let's speed it up a little bit more. So we can see the speed at which Earth is going towards this black hole is increasing exponentially as it gets closer. And there's our problem. It just drifted off into one black hole. So, you know what the problem is? It's not perfect. Something is not right with this black hole. Or something is not right with this black hole. Or it's a floating point error where the computer is just confused. That happens. Computers, when they use floating points, which are a type of number in computers, they have to round, and sometimes a little fraction of a number gets cut off, and because of that, you won't get the same answer every time, which can cause things like this to not be 100% accurate. So the question is, how can we make it 100% accurate? Well, probably our first step would be doing this with something larger, something that has more attraction to each black hole. So let's try doing this with the sun. Let's see if the sun is affected by this in the same way, and if this problem can be overcome later with the Earth. Well, it can, technically, if we lock it, position lock it, but I feel like that's slightly cheating in this point, but we'll see if we have to do that in the future. So, no, the effect just seems to be much greater here. The sun is quickly speeding up, and we can already see it's moving this way, towards this black hole right here, and the sun is just going to go that way. There's not much we can do about it, and it's just going to exponentially increase in speed, and it's going to basically end. Oh, I know the problem. I actually do know the problem. That makes sense. We've been doing testing on these black holes, and we haven't been making sure their mass is equal afterwards. So 10, 1, 2, 3, 1, 2, 3 suns, because it only shows that, but technically it's not actually at that mass. Yeah, this one right here has more. This one here may have a little bit more, just not enough to show. Same with this. Same with this. Yep, this one's more. So they aren't equal. There we go. There's an answer to our question on what's wrong. Another thing, are their radius? Yes, the radii are equal. Funny thing is, they say they have velocity, but they don't actually because they're position locked. So, let's try a position locked Earth in the middle of these and see if that was our problem. First, let's save this as the Ripper. Replace it. And let's position it. So we're going to have to do half an AU in each direction. Boop. Oh, that's 1. Wait, that's not 1. That was just 10 million. 10 million meters. Yes, that's not what we wanted. Okay, so there we go. That's in the middle. And now if we do motion, position. First, I want to see if it actually moves. Because if it moves, like I said, floating point errors should cause it to speed up over time. It's not. It's not. I think we did it. Nope. Earth is actually not being attracted to one more than the other. And it just ripped itself apart. Unless it actually went towards something. Oh, I was clicking on a black hole that whole time. Shoot. Okay, let's just open the Ripper, because this one has it all. The Earth isn't in the correct spot, but it has all the black holes equaling the exact same amount. This time, let's make sure we're looking at the right thing here. Okay. Earth's motion. Yes. We are gaining, which is disappointing. But it's fine. Like I said, it's not going to be perfect. Maybe in the future we will see more accurate simulations because of technology getting better, but you cannot blame the Universe Sandbox 2 team for this, because I don't think there's much they can do about it, except for making the game extremely laggy and making it super accurate. So now, Earth exactly between each black hole, every force equal in every direction. What will actually happen? And there we go, there's our first answer. A wave of material was just ripped off of the Earth extremely quickly. and Earth explodes in every direction, ripped apart so quickly that it actually is hard to comprehend. Then the last amount is pulled in this direction, probably because this black hole happened to catch a little bit of the debris from earlier, and that looks like the exact reason. And look at that. All that's left of Earth is, if we can get this in moons, pretty much a few millions of the moon left over. And that is proof that this is working. Good job. So now let's do something bigger. Let's look at the sun being ripped apart by these black holes. So if we go to the sun, we position lock it and set its position to the exact center here. And press play. This should happen more quickly because of the amount of gravity exerted from the sun itself compared to the Earth, but who knows? And more quickly than I can actually press. So now we can actually see direct lines. Now, some of the material is going the slower route, but we can see a plus sign where each black hole is taking its quarter of the sun's mass and quickly eating it. Interesting. So it works. 100% it is functional and it's working as intended. But let's go bigger. What's the biggest object that we can fit in here? Something not ridiculous, but something with a lot of mass. I would say this, but it touches a tiny bit. Actually, we can put Rigel in. We're just gonna have to get a little bit creative. So let's get Rigel. Let's do its position first. Position lock on, and now we're going to go down to our velocity. We're going, not velocity, no, that would have been bad. We want to go to its position. Where is its position? There we go. Boom, boom, boom. Shoot, why is this glitching out? Okay, now we're just going to increase its density, and its mass is locked. Huh. Why is it not shrinking? Oh, I think I have to press play to do that. It's fine, we can just... Do I have to press play? Oh well. Looks like it's instantly being ripped apart in every direction. Shoot. Well, I can't say that's what not what I expected, but looking good. It works. So we did it. We successfully figured out how to get the Ripper fixed, and because that was just kind of a continuation of the last episode, let's go and do something new very quickly before we end. Let's open a new simulation, and how about we just do a nice collision, and we will do... Let's just make a circle around Earth. Let's make a circle around Earth at as equal distances as we can. We're not going to go perfect here, but we're going to try to... Okay, so we're going to do boom, 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 and that looks good. And let's watch this collision in slow motion, and then we'll see what we do next time. here we go. So as the many Earths near, we're going to see a little bit of rush limit kicking in as a little bit of materials ripped off of the Earths, but it looks like they're all going to hit at a close time. Looks like this side is much closer. Let's slow down a bit. And collision time. These two are actually ripping each other's atmospheres off, but that doesn't really matter compared to the carnage that's about to occur. These two are actually colliding now. Now they're about to hit main Earth. Main Earth is taking quite the beating, and the rest are following suit. And there we go. Look at the destruction. Every single Earth is ripping each other apart, and it looks like we're going to have one survivor. Maybe two. Those two will come back at each other, though, any second now. Ooh, that one has a ring that's probably going to form a moon in a few million years. Let's give it a bit more time, and let's facilitate the battle by putting this Earth in 0 velocity and this Earth in 0 velocity, so they are forced to follow each other. And here we go. Charm, give me 20 seconds. I'm just finishing the video, man. Here we go. Let's finish it up, and the final collision. Charm, do you want to sing along to the final countdown? Oh, there's the explosion. So guys, thank you for watching. If you enjoyed this video, make sure to leave a like and subscribe. Maybe I'll put out a save file for the Ripper if enough of you want it. I don't know how you actually use save files in this game, but there's gotta be a way. And I will see you all next time. Peace.